video of me dunking on LeBron James or something. I'll put that up there. Yeah, that's what I'll do. There's a guy that beat Michael Jordan one-on-one. He went to one of his luxury camps. Yeah, there was one person who did it. He's just some average guy, too. He just hit a couple J's and he did it. So that's pretty good. All right, so remember, put this stuff on a compass, these kind of problems. Don't just start running numbers. Look at it. Okay? So you're doing A, B, C. Now, when I go from A to B, that ain't 230, 54. I can just look at it and see that. You all understand what I'm talking about there? And this is right on that review that I just handed out to you, this thing. So don't use 230, 54 for that line. You got to take 180 from it, see? And then you got to get, what, 50, 54, right? Is that right? Yeah. Okay, now that looks right. So the thing on these layout problems, if you remember in the homework, I gave you the compass circle and I told you to fill in the circle. And on those ones where you had the instruments set up and you were turning angles and the Kogo stuff, I gave you a little grid and I had you draw it up. You know, that was to help you so you could see what you're doing, okay? So we got that, and now we're going backwards, right? 86, 59. So you're going to take the 50, 54. And you're going to take away the 8659, but that's you can't do that, can you? Because you can't take 86 away from 50. You really don't want to go into negative azimuths. That's not generally how I like to do that, okay? Azimuths are positive by definition. So add 360, and then we get 41054. Now I can take 86 away from it, okay? But I can't, shucks, I'm a little out of room here, 409 now. So instead of 410, 54, so what did I do? I got 410, 54, and I'm going to take the 86, 59 away, right? But I can't take 59 from 54, so I got to make that 409, right? And then I add 60 to it, so that's 114. Now, I've had another error I've had people make is they carry 100 over because they're so used to doing decimal. When you carry over, you carry 60, not 100, but 60. Okay, remember that? That's another little common error people make. Okay, so what are we going to do now? We're going to get 5 and 10, so that's 55, and then that's working out now, isn't it? So 323, 55. Y'all okay with that? Well, there's other ways you could do it, but
I was like Googling it because I didn't know how to do it. And it was like times by 360 or 2,000 seconds and stuff like this.
Yeah, you got all the Google scan. It ain't gonna work. Yeah. So, okay, but just the whole thing is look at it. You know, there's a few rules on how to handle it, but just be sure you're looking at it so that it makes sense. I mean, how else could you do this if you wanted? I mean, you know, it's not. Surveyors actually, they're a lot handier with bearings and stuff. You know, they don't use all the methods I do because they do it a lot and they get pretty good at how they do it. But that's 50-54 right there, isn't it? And then how much do we got over here? Oops, we want an azimuth though. I'm sorry, we're doing azimuths. Okay, if you want another way you could have done this was you're taking 50, you're going back to the left, 86-59. 50-54 will get you due north, won't it? Yeah. So 86-59, take away the 50-54. There's 05. And what do you got left? 3605. So now you're due north and you're coming back 3605. Okay? I mean, that's another way you could do it too. You know, there's many ways to do the calculations. The important thing is to have the picture so you're not just throwing numbers around.
What number would you subtract?
Well, you got to take it away from 360 because you're coming off a due north, see?
Yeah.
But whenever I'm subtracting from 360, I automatically just write it 359.60 because I know I got to carry. You know what I mean? I got to, so I just do that automatically. Then just take away the 3605. I mean, here's another way to do it, and you get the same answer. it varies a little bit just depending on, you know, the physically how it's set up. I mean,
Can't you just add the 180 to the 230 and then subtract the angle?
yeah, that'd work too. Because if you add 180 to 230, you get to that 409, the 410, 54. And then, you know, and you're right. Then you're right here again. You're right. I mean, I took away 180, then I added 360. Probably quicker just to add 180. Yeah, but you kind of had to look ahead to see you needed to do that, you know. So lots of ways to do these, okay? Okay. All right, find angle ABC. Now, the way I teach this is get everything in azimuths, okay? But that's the easiest, most systematic way to do it. This one already is an azimuth. It's already pointing the right direction. That one's fine. This one isn't, though. So I got to take that southeast. So 180 straight down. I got to take away the 6527 to get the azimuth. You know, good with that? So I'm going to take away, I'm going to subtract. So whenever I'm going to subtract, I just automatically carry the 1 degree over because I know I'm probably going to have to do that, okay? So then I'm going to take away the 6527, 33, 4, 114, 33. So I got 114, 33, and I'm taking away 62, 31, 02, 2, 52, 02. There you go. Well, you know, and again, there's other ways. Well, that one's probably the best way to do that one. There's other ways to do them, but just get a picture. I mean, and that's one of those things, you know, sometimes we learn stuff in school, you know, we learn it in school and then we move on with our lives and we don't worry about it. But in surveying, you got to see it. If you can't see it and you're out in the field, you can get yourself into trouble. Yeah, question.
So what is the 114.33 symbolize?
That's the azimuth from B to C. That's the azimuth because I'm taking away. See, I've got a bearing. A bearing comes off at due south. So I'm coming off of 180 and I'm going that way is what I'm doing. See? Now, you know, some bearings you add, some you subtract. It depends which quadrant you're in, you know. If you're in southeast or northwest, you subtract. If you're in northeast and southwest, you add to go from a bearing to an azimuth. Okay. I'm just kind of running through these. I mean, you know, obviously you're the ones that you probably want to run through these too, you know. Okay, we good with that one? Mm-hmm. Okay, now these things get a little involved. So this is that radial surveying stuff. So again, I really suggest you draw a picture. Instruments at 1200, 1400. Now remember, the northings come first. Back sight is something that's further north and further east. So the back sight's over there. And that's 1500, 1500. And then you're going to foresight C, which is further south and also a little bit further north. So that's over here. Okay. So that's what you're up to with this. So start with a picture so you get some idea of what it is you're doing. All right. Now we want to know how are we going to set point C? What angle will we turn? What distance will we shoot? Okay. So when you do these, if you want to get from A to C, what you do, you got to switch it around. So to get from A to C, you take C minus A is how you do it. And that's right on the formula sheet, upper right, where that switch on the letters is shown. So remember that's there. Okay, so if I take C, what I got for C is 1080. Now I'm going to run out of room here. So 1080 and 1490. And then I'm going to take away A, 1200, 1400. Okay, remember that's northing, easting. That's how those coordinates are laid out. Okay, so I'm going to get 1080 minus 1200, that's minus 120. And then I got 1490 minus 1400, that's a positive 90. So when I look at what I'm doing here, that looks reasonable, doesn't it? I'm coming down 1200, I'm going over 90. Now, once you've got those numbers, the rest of the stuff's right on the formula sheet. So to get the distance, you just take the square root of the sum of the squares. So that's how far you're going to shoot from A to get to C. And then to get the azimuth, which is what you're going to want to know here so you can figure out that angle in between, you're going to take the arctan of whatever the heck it is there. I think it's 90 over negative 120. Okay. And remember what arctan is tan to the minus 1 on your calculator. All right, so take 90 divided by 120. All right, then take an inverse tangent of that. But be careful on this stuff. So I'm getting negative 36 point, whatever, negative 36. Now carry these out a long way. Okay. Because you want to, now I want to convert that into minutes. Okay. So what I'm going to do, I'm going to take negative 36 degrees plus 0.8699 times 60, right? And actually it's, well, I'll put the negative outside the parenthesis there. There we go. So that's 52. So I'm getting negative 36 degrees, 52 minutes is what I'm getting out of that when I run that number. Okay. Now, when I look at that line going from A to C, is that an azimuth of negative 3652? Yeah, it don't look right, does it? See, negative 3652 is up this way, starting due north. So that's a problem with calculators. They don't know the difference between those two lines. It's up to you to see that. So what you're going to do is you're going to add 180 to that to get your azimuth. So you got negative 36 degrees, 52 minutes. You're going to want to add 180 to get that straight. Okay? And so that's where this 143.08 comes from. So that's the azimuth on this line right here. It's 143.08. Doing all right with that? Okay, now you do the same thing to get from A to B. You're going to take B minus A. So B is 1500. 1500. Take away A. And what's A again? It's 1200, 1400. So that's 300, 100. Okay. So to get the azimuth from A to B, just do that arctan business again. .43. Carry a couple more figures, 49. And what that comes out to be is 18 degrees, 26 minutes. Okay, so that's 1826. That looks about right. And this one ahead is 143.08. So you just want to find the difference, and the difference is 124.42. That's the difference in the two angles. So what we're saying here is if you put the instrument here on A, look back at B, and you want to set point C, you're going to tell the crew there to turn a 124.42 and shoot out 150 feet, set the point, and that'll be point C in the ground. Okay. You okay with that? All right. Next one's similar. You got the gun at A. You're looking back at B. Now that's the same line as before. I just did that so we weren't sitting here calculating forever. So that's 1826 back. And that's the same line as we used on the previous problem. And then we're going to turn a 5632. And we're going to shoot 123.78. And we want to know, where are we? Okay, so this is point D. All right. So you're at 1826 and you turn a 5632, 58, 74.58. That's your azimuth looking ahead. So what you've got then is a line with an azimuth of 74 degrees, 58 minutes. And you're going to shoot 123.78. And you want to figure out where D is. And you're starting at A, that's 1200, 1400. So what you want to do is just get the latitudes and departures on that line. And then just add them to what you got for A. Okay. Now, most calculators don't like doing DMS, degrees, minutes, and seconds. So make it decimal and carry it out. You know, there's no harm in carrying it out too far when you're doing these calculations. Or just keep them in your calculator. That's probably the safest way to do it. And then what you're going to do to get your latitude, and this is right on the formula sheet, is you're going to take cosine of that angle times the distance. 123.78. And use your memory and all that stuff. It's just more efficient. And we'll take a cosine of that, and then we'll multiply it by 123.78. 32.11. Is that right? Yep. We got it. That's good. Okay, then the departure. Take sine. Times 123.78. $119.54. Okay. So that's the delta y and the delta x for that line from A to D. And then once you've got that, what do you do from there? You take your original coordinate, so 1200 plus the latitude. And then your other original point there, which is whatever the heck it is, 1400 plus the departure. And what you come up with is your final coordinate. There you go. Okay. So that's that one. That's laying a point out, or actually that's measuring. Or what are we doing there? Yeah, we're measuring a point there, finding the coordinate of it. Okay. Okay, this one here, you start off with the point on the ground, add the little HI, that gets you where the telescope's at. Then you're going to want to take 90 minus 97.18. So that's negative 17 degrees, 18 minutes. So that's negative 7 plus 18 over 60, right? Negative 7.3 degrees. So then you're going to take sine of the negative 7.3 degrees times that distance, the 178.92. So 178.92 times the sine of 7.3. It's 2273. Okay, so you start at 223.57, you go up to the telescope at 540, then you drop by that amount right there, which is 2273 based on the trig. Then you drop 6 more feet to get down to the ground, because what you want is the elevation on the ground. And you get to 200.24. Okay. So that one's just a bit of trig there on that angle down. That last one, just look for points that are above and below 300. So that goes. So I just go through it first and look for points above and below 300. that it? Where's the other? Oh, on the diagonal? Yeah, we'll get that later. So the diagonals usually I kind of look at next. So we'll start with the main grid points. Okay, so 305 and 280, there's 25-foot difference. So we're 5 out of 25, so that's about 20%. Oh, I see. It's over here, right? Where are we? Oh, over here. Okay, thanks. I get it, what you're saying now. Thanks. There we go. So this one. Yeah. Thanks. All right, 310 and 290. About right in the middle, eh? 1, 2, 3, 4, 5. And then 305 and 290 over on that side, and then 290 and 305. I don't know, is that it, more or less? Something like that. Okay. So what I'm doing there, I'm finding points above and below 300. Then I'm interpolating where the 300 elevation would be. All right, so I'm just doing a linear interpolation there. So this one, I don't know, I haven't made it up yet, but it probably won't be addressing, I think it was Luke's earlier remark there. I don't know if I'll have quite as many questions on this one. Probably, you know. What's that? I mean, just on the test itself. You know, that midterm did have a fair number of kind of short answer kind of questions. Mm-hmm. This one might be a little more tilted towards calculation. So okay. I don't know. I'm just thinking off the top of my head. That's always dangerous to do before I've written it. But okay. So that's just a bit of a review. Okay, so good with that. All right.
The only thing